Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 6, Lesson 2 on features of functions. Now last time, or in the last lesson, we looked at what a function was, right? And we saw that functions could be represented in all sorts of forms. Equations, graphs, tables, ordered pairs. Today we're going to be working mostly with graphs as we talk about different features of functions, things that functions have about them. So let's jump right into that in the first exercise. Now recall that functions are simply rules that assign exactly one output for a given input. Functions have some specialized terminology associated with them. So let's begin by looking at some of that terminology, right? Beginning with what we call the domain and range. Let me bring this up a little bit so that you can see it better. The domain of a function is simply the set of all input values to a function. And you can oftentimes think of those as just the x values. So all of the inputs are what are known as the domain of the function. Now the range of a function is the set of all outputs of the function. One thing that's a little bit dangerous is that the word range gets used a lot in math. It's used in statistics, it's used in function analysis, it's used in a lot of different areas, all right? But in the area of functions, the domain are all the x values, all the inputs, and the range is all the outputs, all the y values. So let's take a look at that definition and using that definition in exercise number 1. A function is defined by the set of ordered pairs shown below, 0, 5, 2, 7, 3, 11, 7, 4, and 10, 5. Letter A, list the domain and range below. Do not repeat values. All right, so let's talk about that a little bit. Again, the domain is all possible inputs to the function, right? And that's pretty easy here, 0, 2, 3, 7, and 10, right? Those are the inputs. The inputs are 0, 2, 3, 7, and 10, right? If you gave me a different input, like x equals 4, I'd say, well, look, I can't give you an output, right? Because 4 is not in the domain of this function. Now the range are the outputs themselves. So it's simple enough, right? I'm going to just start listing the y values. The outputs are 5, 7, 11, 4, and 5. But I'm not going to list the 5 again. Mr. Weiler, will we get points marked off if we list the 5 again? Well, I don't know. That's up to your teacher. But you shouldn't, okay? The idea just simply is, well, what values of y come out of this function? Well, the values 4, 5, 7, and 11 come out. Do they have to be in order? No. They don't. A set is just a collection of stuff, so there's absolutely no need for the range in this case to be listed in any kind of numerical order. But, if you will, it's sort of bad form to list the 5 twice. We don't need to, right? All this is telling us is that the outputs are 5, 7, 11, and 4. Now, letter B. Explain why adding the ordered pair 2, 1 to this set would mean that it is no longer a function. All right, this is a really, really important question because it goes at the heart of what a function is. So imagine for a moment that I kind of scratched this out, put comma, 2, 1. Why would it now be problematic to claim that this is a function? Pause the video now and see if you can figure that out. Well, let's go back to what a function is. A function is a rule given in lots of different forms, including sets of ordered pairs, that for a given input, you get only one output. For a given value of x, there is only one value of y that comes along with it. But see, that's why this point is so problematic, because we also have this point. So because of this point cannot be allowed due to the fact that an input of 2, right, would now have 2 x values, two outputs, y equals 7 and y equals 1. Therefore, it would no longer fit the definition of a function because the definition of a function is for any given x value, there can be only one y value that matches up with it. So my explanation would be the input x equals 2 would have two outputs. And that's probably a good enough explanation, but I'm going to list those two outputs, y equals 7 and y equals 1. All right, very, very important. Oftentimes when you're tested on functions, this idea comes up, this idea that, look, you cannot have inputs that repeat. Let me say that again. Inputs can't repeat. X values can't show up more than once. Y values can, right? In fact, in this table, get rid of this, or not table, but in this collection of ordered pairs, a y value of 5 repeats. But that's okay, because an x value of 0 only has one y value that goes with it, and an x value of 10 only has one y value that goes with it. There's nothing wrong with that from a function's perspective, right? What's problematic is all of a sudden if I say, here's an input, what are the outputs? Can you imagine if I like tossed a ball into the air, right? And I said, hey, how far above the ground is it when like 2 seconds after I tossed the ball in the air? And you said, well, the ball's at 15 feet above the ground and 22 feet above the ground. Somebody would be like, wait, no. Like the ball can't be at both of those spots for that input. There's got to be only one output when I put in, 3 seconds after I tossed the ball in the air. Okay, let's keep going and talk about other features of functions. Now, most of the other features of functions that we're going to talk about really are best thought about in terms of the graphs. We could still look at them in terms of ordered pairs and tables and all of that, but graphs are particularly helpful. And again, remember with the graphs, the x values are the input, the y values are the function values themselves. They're the output, right? So let's take a look at that in exercise number 2. The graph below shows y as a function of x. Answer the following question. What is the maximum value the function reaches? All right, so let's talk about this phrase. The maximum value the function reaches. Okay, the values of the function are the outputs. They're the outputs. So with that throwing a ball in the air, they're the heights of the ball, right? So if I see something like what is the maximum value of the function, I'm looking for the largest y value. The largest y value. And of course, we can figure that out very easily looking at a graph by just saying, hey, what's the highest point on the graph? Oh, it's right there, right? And that's at a y value of 8, right? So the maximum value this function reaches is 8. But of course, we have an associated question with that. Take a look at letter B. At what input does it reach this maximum value? Right? In that case, what we're looking for is the x value that goes with that y value, or possibly x values. Now, in this case, there is only one peak right there, and it occurs at an x value, I believe, of 7, right? Now again, those are two different things. Like I would never want to say that the maximum value was 7, 8, because 7, 8 isn't a value. It's a set of ordered pairs. The largest value on this function is 8. And again, imagine that we sort of had that graph of a ball going up and coming back down, right? Saying what's the function's maximum value would just be like, hey, what's the greatest height that the ball reaches? Then question B would be, hey, what time does it reach that value, right? Something like that. Now, of course, if we can ask about the maximum value of the function, we can also ask about the minimum value of the function and at what endpoint does it reach the minimum. So I'd like you to pause the video now and figure out what the minimum value of the function is and the input at which it reaches that minimum. Pause the video now and see what you get. All right, well, the minimum is literally the lowest value. It's down here, right? And that minimum value is going to be y equals -4. And what x value does it reach it at? It looks like it reaches at x equals 1. All right, simple enough. The last question, letter E. Is the value 10 in the range of this function? Explain. Well, pause the video now, take a look at the front side of the sheet, and think about what the range is and whether or not 10 would be in the range. Pause the video now. Well, the range, let's write this down real quick, right? The range is all the outputs, which are the y values. Now, we know that the smallest y value, right? The smallest y value is -4, and the largest y value is 8. So is 10 in the range? No, because it doesn't fall between -4 and 8. No, because it doesn't fall between -4 and 8, right? Every other value, decimals and irrational numbers, every other value, we will hit between -4 and 8, somewhere, right? Somewhere. Like for instance, we hit a y value of 4 right here with an x value of 5. We hit a y value of 1 right here at an x value of 0. Right? We hit a y value of 5 right here. So every other output is hit between -4 and 8, but 10 is too big, right? The maximum value is 8. There's no way we're ever going to reach 10. All right, so maximum and minimum values of functions and what inputs they're hit at. Because, you might want to know that, right? If you had some kind of a graph that was, showing you like the price, let's say, of some kind of stock, or something like that on the stock market, probably going down, but whatever. You might want to know what is the maximum value the stock was at and what day did it hit it. All right, let's take a look at exercise 3 and another graph. Using the same function graph, actually it's the same graph, using the same function graph as in exercise number 2, answer the following questions. When deciding whether a function is increasing or decreasing, always read the graph from left to right. All right, so let's talk about this a little bit, right? So we always want to read a graph from left to right, like we're reading a sheet of paper. And the reason we want to do that is that as we look at a graph moving from left to right, the x value, the input to the function, is getting larger, right? As you move from left to right, you are always getting larger in terms of x. The question is the output getting larger, in which case the function is increasing, or is the output getting smaller, in which case the input is decreasing? So let's take a look at that in letter A. There are 4 distinct portions of this function. For each interval below, state whether the function is increasing or decreasing. All right, so let's take a look from x equals -4 to x equals -2. Let's find those 2 points on the graph, right? X equals -4 is this point. X equals -2 is this point. Now, if I were to travel along this graph from this point to this point, and I would have to go from this one to this one because I need to go from left to right, I need to always be moving in this direction, then of course what I see is that the y values are getting larger, right? As I move from left to right, the y values are getting larger, right? I'm going uphill, and therefore the function is increasing from -4 to -2. Now let's also take a look at it from -2 to +1. And again, these are always the input values. So we already have where -2 is. There's +1, right? And of course, if I go from -2 to +1, then I'm going downhill on this function. So the function is decreasing, right? Going uphill, then downhill. Why don't you finish the last 2? All right, so not surprisingly, here's x equals 1, here's x equals 7, and between that stretch, we have this nice straight line on our function. The function is going up, so it's increasing, and then from 7 to 10, the function is going down, so it's decreasing. By the way, not a huge shock that it alternates, increasing, decreasing, increasing, decreasing. You could have a scenario where a function kind of increases pauses for a minute, then increases again, pauses for a minute, then increases again, etc. All right, so you can have increasing to increasing to increasing to increasing, and likewise with the decreasing. But in this case, we're increasing, then decreasing, then increasing, and then decreasing again. All right? Now, very important are those transition points. Let's take a look at letter B. The location where a function changes direction, so when it goes from increasing to decreasing, or decreasing to increasing, is known as a turning point. State the coordinates of all turning points. Now, a turning point is also known as a vertex of a function, all right? And they are really simple to spot. Real easy, right? Here's a turning point right here at the coordinate -2, +5, right? A turning point is literally where a function's inputs go from increasing to decreasing, and from decreasing to increasing, etc. So why don't you list the other turning points of this function? All right, so here's another one down here. That's at the point 1, -4. And here's another one up here, and that's at the point 7, 8. There's hardly anything that is easier to spot on the graph of a function than its turning points. I once gave a graph of a function to my daughter who was in 5th grade, and I said, where do you think the turning points are? And she was like, there. You know what I mean? The name itself kind of implies what we're looking for in terms of turning points. But the technical definition is it's where a function changes from increasing to decreasing, that would be one of these, or decreasing to increasing, that would be one of these. Let's keep going. One more problem, let's take a look. Exercise number 4. Given the graph of the function below, answer the following questions. Now, I think you can actually answer all of these. Every single one of these is something that we've covered so far in this lesson. So what I'd like you to do is pause the video and try to answer A, B, and C. Take, 5 minutes or so. Should be able to get all of them at that point. And then we'll go through them. All right, the first thing they ask us to do is the minimum and the maximum values of the function. Remember, those are the y values, not the x values. That would be simple. Here's the smallest x value, here's the largest x value. You never really asked that, right? So the minimum y value is going to be the lowest y value on the graph, and that's at -8. And in fact, it's really kind of helpful to do a y with a little subscript min. Y min is -8. All right, and then let's figure out what y max is, right? That's going to be the absolute peak point. It's right here. That appears to be at a y value of 6, so my maximum y value is 6. All right, simple enough. Letter B asks us, from x equals -7 to x equals -3, is the function increasing or decreasing? Great. Well, in the last time when we did increasing and decreasing, it was kind of easy because I did the first two for you, and then it just kind of kept alternating from there on out. But here, you got to make your own call. So here's x equals -7. Here's x equals -3. Well, sorry, that's not right. I read that graph just a little bit too quick. My apologies. Here's x equals -7. Here's x equals -3. Now, of course, whether you're going uphill or downhill between these two x values depends on which direction you're kind of moving in. So make sure, as always, to be reading this graph from left to right. In other words, start at the smaller x value, move to the larger x value, and what we see is in this stretch, the function is going downhill, so the function is decreasing on that interval. All right? And finally, we want the coordinates of all turning points. That's easy enough. I've already circled 2 of the turning points. Let me circle the other 2 turning points, right? There's a total of 4 turning points here. They have coordinates of -7, +4, -3, -4. Let's see, this one is at +3, +6. And finally, we have one at +7, -8. And that's it, right? Let's wrap this up. Let's talk about what we saw today. So functions have lots of features. There's even some more that we're going to see in follow-up lessons. But We saw some of the very important ones today. For instance, right, every function has a set of inputs, that's called the domain, and a set of outputs that come from those inputs, that's called the range. Those are easy enough to identify. Right, but what we also saw were things like whether or not a function was increasing or decreasing on a particular interval of x values, an interval of inputs, and also, right, we saw the maximum and the minimum values of a function. Most of the time, functions have a largest output and a smallest output. Not always. You could certainly have like a function that's a straight line that kind of goes forever in two directions, and maybe the minimum is negative infinity and the maximum is positive infinity, in which case we'd say there is no minimum and maximum. All right, so all of these are very important along with the very critical idea of a turning point of a function, where a function goes from increasing to decreasing or vice versa. Again, we'll play around with a lot more of these features as we move forward in our unit on functions. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.